Hello, so in this video we will talk about how to calculate the variance of a multinomial distribution. So as a recap, this is an introduction of the multinomial distribution that we have an experiment that can result in R possible outcomes and probability of and the experiment resulting in the ith outcome is given by Pi and the experiment is performed n number of times. Okay, and uh, each performing of an experiment is independent of the other performing. Okay, and then let xi be the number of times ith outcome I occurs or ith outcome occurs, with I is from uh, 1 to r. So I can be any integer between 1 to r. Okay, and then xi can be any integer between 0 to n, because 0 is telling us the event when xi never happens at all, when ith outcome never happens at all, and n tells us the event when every time we get ith outcome. Okay, the probability, the joint probability that x1 is some x1, x2 is some x2, and up to xr is some xr is known as the multinomial distribution, and the probability mass function is given by this expression, which is n factorial divided by x1 factorial, x2 factorial up to xr factorial times p1 to the x1, p2 to the x2 up to pr to the xr. Okay, and due to the definition of probability, this sum should be equal to 1. Okay, and the expected value uh, of this e to the xi is n times pi. Now in this part, what we have finding, we have to find variance of xi. So without loss of generality, we will find variance of x1, which is equal to what? Which is equal to e to the x1 squared minus e to the x1 squared. So which is equal to, so this guy is equal to what? This guy we already have it here. So this guy is equal to n squared p1 squared. Okay, now we are interested in finding the second moment. Okay, so let's start now. So we start with the definition. So we have e to the x1 squared. This is equal to x1 squared p x1 is equal to x1, and we sum all the values of x1, and what did we say? X1 can take all values between 0 and n. Okay, now so if I put x1 is equal to 0, what do I get here? I get a 0 here, so I can immediately change it to x1 is equal to 1 to n. Okay, x1 squared p x1 is equal to x1. Okay, now what is p x1 is equal to x1? So this is equal to so I'll say this is equal to x1 is equal to 1 to n x1 squared. So if I have to separate x1 from this joint PMF, so what do? I sum over all the variables except x1. Okay, or in other words, I say I marginalize with respect to x1. So then this guy is equal to what? This guy is equal to n factorial divided by x1 factorial up to xr factorial p1 to the x1 up to pr to the xr. Correct? Okay. Now what I'm going to do is I'm going to write x squared as x times x. So let me do it just to save space. Let me do it right here. I'll just cut it here and I'll say x times x1 times x1. Okay, now I'm going to combine this x1 with this x1 factorial. So this will give me x1 is equal to 1 to n x1, and then I will say x2 up to xr such that their sum is n minus x1, and then I will say n factorial divided by x1 minus 1 factorial x2 factorial up to xr factorial, and then I'll say p1 to the x1 up to pr to the xr. Correct? Okay. Then what? Now I have to make a change of variables. So my change of variables is going to look like this. So now I will say this. I will say let x1 prime, this is equal to x1 minus 1, which means that x1 is equal to x1 prime plus 1. Okay, and then if x1 goes from 1 to n, my x1 prime will go from 0 to n minus 1. Correct? Okay, so now I will do this. From here, I will say my e to the x1 squared, this is equal to x1 prime plus 1. So this is x1 prime, this is equal to 0 to n minus 1. Then I will say this guy again, x2 up to xr, and then x2 plus xr, this is equal to n minus x1 prime minus 1, and then I will say n factorial divided by x1 prime factorial up to xr factorial p1 to the x1 prime plus 1 p2 to the x2 up to pr to the xr. Now note that I have x1 prime plus 1 here, so I can actually split it into two summations. Okay, so now what I'm going to do is I'm going to do this. So I'm going to do this. So this is equal to, my first summation looks like this: x1 prime, and then I have n factorial over x1 prime factorial up to xr factorial, and then p1 x1 prime plus 1 up to pr. This is my first summation. And then again x1 prime, this is 0 to n minus 1, and then this is the same thing, x2 up to xr, such that their sum, this is equal to n minus x1 prime minus 1. Okay, so this is different, okay, from here. Then the next summation looks like this. Next summation is, there's no x1 and the rest is the same. So x1 prime, this is 0 to n minus 1, and then x2 up to xr, and then x2 plus up to xr, this is equal to n minus x1 prime minus 1, and then again n factorial divided by x1 prime factorial up to xr factorial, then p1 x1 plus 1 up to pr xr. Okay, so now I'm going to do two things, actually three things here. First of all, I'm going to combine these two summations into one summation. So in other words, I'm going to write like this. I'm going to say x1 prime up to xr such that x1 prime plus xr, this is equal to n minus 1, and this is x1 prime, and then what I'm going to do is I'm going to write this n factorial as, I'll take n out and I'll say n minus 1 factorial, and then divided by x1 prime factorial up to xr factorial, and from here I'm going to take this p1 out as well. So p1 times s, and then this becomes p1 to the x1 prime up to pr to the xr, and then I'm going to do exactly the same thing here. So this will become plus here n times p1, and then I have what? I have x1 prime up to xr such that x1 prime plus xr, this is equal to n minus 1, and then I have exactly the same thing. I'll say n minus 1 factorial divided by x1 prime factorial, not plus. So then I will say up to xr factorial p1 x1 prime up to pr x to the r. Okay. Now, just to save some space, I'm going to erase some of the parts here. Now, the first summation is what? So the first summation is n times p1 times expected value of a multinomial with n replaced by n minus 1 with parameter n minus 1. Okay. The second one is what? Sum of probabilities of a multinomial and again n minus 1 is the parameter here. Okay, what is this guy? So this guy is, we already know that the expected value is n times pi, okay, or p1, for this case p1, but then we have a parameter n minus 1, so we'll say n p1 times n minus 1 p1. This guy is what? This guy is just 1, so we'll say this, say n times p1. So this is my second moment here. Okay, now, so what is the variance? So let's create some more. So variance is what? This is equal to e to ex1 squared minus what? N squared p1 squared. So this is equal to this guy. So n p1 n minus 1 p1 plus n p1 minus n squared p1 squared. So if you just do basic algebra here, we will end up with n p1 times 1 minus p1. So this is the variance of x1, and x1 is what? The number of times we get the outcome of the first outcome. Okay, and we can generalize it to variance of xi, and and we just can replace variance of xi is equal to n times pi times 1 minus pi. So it was not hard, it's just long manipulations of summations and to observe that what is the expectation value, I mean how did we derive the expected value, and using it twice, once for the probability, sum of probability, and once for the expected value. So this is it about the variance of a multinomial distribution. Thanks for watching, hope it was easy to understand, hope you liked the video.